Yes, loving Sai Ram to everyone.
Sai Ram.
So I hope whatever I taught yesterday, it was good and you could do in the test. And now we'll, in continuation with that, we'll start with the next topic. And as we have done the image formation yesterday, right?
Yes.
Then what kind of images do we get? Then uses of mirrors, both the mirrors, concave as well as convex, right? Now we come to the next step, and that is the sign conventions, right? Sign conventions for mirrors. Now what do you mean by the sign conventions for mirrors? Sign, we know that plus minus, right? These are the two signs which we are going to take here. And conventions means rules. So what are the rules according to which we will assign the signs to the various distances which we are going to measure in the mirrors, right? Now all of you must have done the coordinate systems. The Cartesian coordinate systems everybody must have done. So what do you do? What do you call this origin? Towards this side we take the x-axis, that is positive distance. This side we take as negative. Here we take as positive, and this negative. This everybody knows?
Yes, ma'am.
So this we will take as the base for the sign conventions, right? Now what are the sign conventions? The first sign convention in the Cartesian coordinate system for the mirrors, it says that all the distances, they are measured with respect to the pole, right? What is pole? Pole is the center of the mirror, right? Which is represented by T. So we say that all the distances, they are measured with respect to the pole, right? Then as a convention we take that the light will always enter from the left side, right?
T का मतलब
बेटा with respect to, WRT means this is with respect to the pole, that all the distances we will measure from the pole. Then the third one, the distances to the right of the pole, they will be taken as positive. This positive, right? Then distances to the left of the pole, they will be taken as negative. Right? Then the distances which are perpendicular to the principal axis in the upward direction, they will be taken as positive. And the last one, that the distance is perpendicular to the principal axis in the downward direction they are taken as negative. Right? So these are the sign conventions which we apply in case of the mirrors. The first one, all the distances are measured with respect to the pole. For example, if I draw a mirror here, this is the pole. We'll start the distances measurement from the pole, right? Then second one, the light will always enter from the left side. That means this is the direction in which the light is coming. It will enter from the left side. Distances to the right of the pole will be taken positive. If you go towards this side, this is right of the pole, right? So this will be taken as positive. And distances to the left of the pole will be taken as negative. Distances perpendicular to the principal axis will be taken as positive. So this is your principal axis.
Yes.
The distances which are perpendicular to the principal axis in the upward direction, they will be positive.
Positive.
The distances which are perpendicular to the principal axis in the negative direction, in the downward direction, they will be taken as negative. Is that clear to everybody?
Yes.
So these are your various sign conventions. Clear? Any question? No question? Right. You're noting down?
Yes.
Okay.
One sir.
Done?
Yes, ma'am.
Chalo, now let's apply these conventions to the mirrors one by one. Let's take concave mirror first. Right, bache? Now this is your concave mirror, right? This is the pole of the concave mirror. Okay? This is focus. This is center of curvature. Right? Now let's apply the sign conventions. Right? Now in optics, the object distance. Object distance means the distance at which the object is kept. ठीक है? मतलब mirror से हमने कितनी दूर पे object को रखा है. That will be called as object distance. And object distance we measure with U. Right? We denote it with U. So this is the sign which we use for the object distance. It is U. Then image distance. Very good. That is represented by V. ठीक है? And focal length that we did yesterday. Focal length small. Very good. That is small. So these are the three symbols which we use for the object distance, image distance, and the focal length. Now let's apply the conventions. We have taken a concave mirror. The distances are measured with respect to the pole. That means we'll start measuring the distances from the pole. So, light is entering from the left side. Okay? We place an object here. So, the distance of this object from the pole, that is taken as U. And as per the conventions, U will be negative because it is to the left of the pole. So U is taken as negative. Now in case of the concave mirror, when we get the real and inverted image, right? So real and inverted image is formed somewhat like this. Okay? So this distance is
Image distance.
V. Very good. This is image distance V. Now V is also to the left of the pole, so V is taken as negative. So here V will also be negative. And the focal length, again the image is formed this side and the focus is also here in front of the mirror to the left of the pole, so focal length is also negative. So F will also be negative. Now there is one more thing, that is the height of the object. This is the height of the object,
Yes, ma'am.
right? And it is where? Perpendicular to the principal axis in the upward direction. So height will also be
Positive.
height we denote by H and it is positive. Now this is image. Your image is inverted in the downward direction. It is perpendicular to the principal axis but in the downward direction. So as per the convention, the distances which are perpendicular to the principal axis in the downward direction, they are taken as negative. So height of the image, that will be negative. Is that clear?
Yes.
Now this is the convention application in most of the cases in the concave mirror, right? Because in case of the concave mirror, the image formed is real and inverted, but there is one exceptional case also, you know, when the object is between pole and the focus. In that case, image is formed
Behind the mirror.
and it is
Size will be
magnified,
large.
right? So when the image is here, like this, right? So in that case, in the exceptional case, what will be the image distance? This will be V. In that case, V is positive and height will also be positive. So this is for the magnified image. Okay? Clear? Okay? So this is how we apply the sign conventions to the concave mirror. In case of the concave mirror, U will be taken as negative, V will also be taken as negative, focal length will also be negative because all these distances, they are lying to the left of the pole, and as per the conventions, the distances measured to the left of the pole, they are taken as negative. Height is positive because it is perpendicular to the principal axis in the upward direction. Here height will be taken as negative because image is inverted. So
Downward.
it is in the downward direction, so it will be taken as negative. In case if the image is virtual and direct, then the image distance will be positive and height will also be positive. Is that clear to everybody?
Yes, ma'am.
Now let's apply these conventions to the convex mirror. Now this is your convex mirror, right, whose reflecting part is curved outwards, right. This is the pole of the convex mirror. Now in this case, focus is behind the mirror, center of curvature is also behind the mirror. Okay? Now we place an object in front of the mirror. Okay? So the object distance is represented by U, right? So U will be negative because it is to the left of the pole. Okay? Then V. Now in case of the convex, yesterday we have done, and you know that all the images, they are virtual, erect and diminished. So when we get the virtual, erect and diminished image, it is formed behind the mirror. That means it is to the right of the pole. So this distance is
Positive.
and V will be
Positive.
Okay. Now focal length, that is the distance between the pole and the focus. It is also to the right of the pole, and as per the conventions it will also be
Positive.
Then height of the object, upright, perpendicular to the principal axis, so it will be
Negative.
Positive, beta. Positive, because negative is taken when it is below the principal axis, but it is above the principal axis, so it will be positive.
Positive.
Okay. Then height of the image, that will also be positive because it is virtual and direct image, so it will be positive. So these are the conventions for the convex mirror. Now here we can generalize one thing. See, if I again draw it for the concave. Okay, object image. So if I write U is negative for concave also,
Yes.
V is negative,
Negative.
focal length is negative,
Negative.
height of the object is positive,
Positive.
and height of the image is negative.
Negative.
See, U is always negative in both the mirrors,
Yes,
because
ma'am.
object will always be kept in front of the mirror,
Mirror.
and as we know that light will enter from the left side, so object will be to the left of the pole. So object distance will always be negative,
Negative.
right? Then V is positive here, because here in
Ma'am,
case of the convex
side.
the image is formed on the right
Right
side
side.
and it is virtual and erect. In that case image is real and inverted and it is formed to the
Left
pole,
side.
so to the left of the pole, so it is negative. Then focal length is positive.
Yes.
Why? Because image the focus is on the behind the mirror on the left side, sorry, right side, and here focal length is negative because focus is on the
Left
side
side.
here, right? So distance is towards the left side of the pole. Then height is positive in both the cases because you will always place the object upright, है ना? सीधे रखेंगे ना मिरर के सामने हम ऑब्जेक्ट को, तो ऑब्जेक्ट की हाइट क्या होगी? हमेशा पॉजिटिव, ठीक है? और इमेज जहाँ पे you will get
Upward.
yes, where you will get virtual and erect image, वर्चुअल इमेज होगी तो वो इरेक्ट होगी,
Yes.
और अगर वर्चुअल एंड इरेक्ट है तो वो कैसी होगी? सीधी होगी, और अगर सीधी होगी तो हाइट क्या होगी? पॉजिटिव।
Positive.
सो अगर इमेज वर्चुअल एंड इरेक्ट है तो हाइट पॉजिटिव है,
Positive.
अगर इमेज रियल एंड इन्वर्टेड है तो हाइट क्या है?
Negative.
Is it clear to everyone?
Yes, yes, ma'am.
Any doubt in sign conventions?
No, ma'am.
Shall we move ahead?
Yes.
Now this is how we applied the sign conventions. Now where do we need these sign conventions? For that we have a very important formula which is called as the mirror formula. Now what does this mirror formula says? It says that 1 upon V plus 1 upon U is equal to F. Very good. Everybody knows the mirror formula, right? So here these signs V, U and F, they have their usual meanings. Usual meanings means, what is V here? V is image distance. What is U here?
Object distance.
U is object distance. And what is F here?
Focal length.
F is the focal length. Clear?
Yes.
Okay. So this relationship which joins the three quantities V, U and F, that is given the name mirror formula, right? And whenever we are solving the numericals, there are three quantities here: image distance, object distance and the focal length. So any two of them will be given to you and you have to find the third one. For that you have to apply the sign conventions. That is why we have done the sign conventions first and then the mirror form.
Yes, ma'am.
Clear to everyone?
Yes, ma'am.
Now, after this, there is one more term, that is magnification. magnification is represented by M, right? Now what is this magnification? What is the significance of this magnification? Why do we find the magnification? Magnification means that whenever we take any object, by what factor the image is magnified and up to what extent the image can be magnified, that will be given by the magnification. So it is a relative term where you will compare the size of the object as well as the size of the image. ठीक है? क्योंकि हम क्या कर रहे हैं, मिरर ले रहे हैं. मिरर में या तो enlarged image बन रही है या diminished बन रही है. ठीक है? तो अब कितनी enlarged हो रही है, कितनी diminished हो रही है, वो कैसे measure करेंगे? With the magnification. So magnification is defined as the ratio of
Image and the ratio divided by ratio of the object.
Right. It is the ratio of height of image to that of height of object. Okay? And just now we have done that height of the image is represented by h dash and height of the object is represented by h. So this is how we find the magnification. Is that clear to everybody?
Yes.
Now after the magnification, there is another formula for magnification. That magnification is also given by, in terms of the distances of image and the object. So magnification is minus V upon U. Okay? This is another formula for magnification. That magnification is minus V upon U, where V is the image distance and U is the object distance. Okay? Now, in this magnification, what is the significance? How do we know that? That what kind of image we have got, whether it is magnified, whether it is diminished or not, right? Now, if the magnification comes out to be negative, it represents that image is real and inverted. If the magnification is positive, it means that the image which you have got, that is virtual and erect. Okay? So, real and inverted image will be obtained if magnification is negative. Virtual and erect image is obtained if magnification is positive. Right? Now, just see that. Please pay attention here. You can note down later on. Magnification is having two things. One is the sign, other one is the number, numerical value, right? So both of them represent some different factors. Negative sign, I tell you, that represents the nature of the image.
Yes.
And the magnitude. Magnitude means the numerical value that represents the size of the image, right? See, magnification is height of the image to height of the object. Now let's say that if magnification comes out to be 1, what does it mean? It means height of the image is equal to the height of the object. Because magnification is obtained by ratio of height of image to that of the object. So if both the factors are same, if height of the image is equal to the height of the object, then we divide two numbers and they are same. So what will be the answer? 1. So if magnification is 1, it means that we have got the same sized image, right? Suppose if I write it is plus 1, it means we have got the virtual erect and same sized image. If it is minus 1, then we have got real inverted and same sized image. Clear? Then suppose if magnification is less than 1, magnification is less than 1, what does it mean? Height of the image and height of the object, this ratio is less than 1. So it means that object size is greater than that of the image. And what kind of image is that? Diminished. So you have got a diminished image. When magnification is 1, then it is same sized. If magnification is less than 1, it is diminished. And if magnification is greater than 1, then in that case we get an enlarged image. Right? So this is how we interpret the answer with the help of the magnification. Clear to everyone? That magnification is what? It is the ratio of height of the object to height of the image to that of the object, right? Magnification is also defined as minus V upon U. This is the one more formula for finding the magnification. So in the magnification we have got two things. One is the sign and one is the mathematical value, numerical value, right? The sign tells us the nature and the numerical value that tells us about the size of the image. If the magnification is negative, image is real and inverted. If magnification is positive, image is virtual and irregular, right? If magnification is 1, the size of the image and object is same. If magnification is greater than 1, the image is enlarged, and if magnification is less than 1, the image is diminished in size, right? So this is all about the mirrors, the mirror formula and the magnification. Now we'll do the numericals based on this. So let's start with the practice, numerical practice.